Welcome, sixth grade. Today we do some estimating with decimals. You guys seem to catch on very quickly, and hopefully, if you have any questions, you find a way to get a hold of me. Contact me through email, contact me on Google Classroom, or some of your parents have my cell phone number for other reasons, so you can contact me that way as well. So, the warm up ordering these decimals. Remember what we do. We write them with decimals lined up. Then, once we line up the decimals and we fill in those extra spaces, we can compare them as if they're regular numbers. 1,870, 1,874, 1,847. They want least first, so this is the least. This is the greatest, and there's the middle one. All right? So you can, that is not correct. My apologies. 1,847 is less than 1,000, so this is the least, this is the greatest, and there's your middle one. All right? Remember, line them up, and then you can compare them like the regular numbers. If we do that down here, maybe you're getting good at it. The big thing that throws people off is something like this. Do you see how 9,600 is more than 9,076? That is usually where people get tripped up. And then 9.060. When we do this comparison, now we look at these. The smallest or the least, 9,060, that would be the least. All right. Then the next, or the biggest, would be this 9,660, and this would be second least, and this would be third least. All right, and we've got those. Now, we also wrote them in words when we say them right. 3 and, notice the connection, 72 thousandths. You look at that number, 72, it's in the thousands, there we are. 6 and 1,258 ten thousandths, because that's the 10 thousandths place. All right? Now, problem there, here we go. To estimate decimal sums, differences, products, and quotients. So how are we going to do this? Clustering, front-end estimation. We're going to do both of these. Front-end means it happens before the problem. All right? When numbers are about the same value, you can use clustering to estimate. Clustering means rounding the decimals to the same value. Rounding them to the same value because they're close together. All right? So here is an example. Nancy wants to cycle, ice skate, and water ski for 30 minutes each day. About how many calories will she burn in all? Cycling, you burn those calories. Ice skating, you burn these calories. And water skiing, you burn these calories. All right? So we know that if we're going to find the total, we would have to add them all together. As we look at these, we can see they're all kind of around the number 170. So we're going to do some front-end estimation and say, 165, we'll call it 170. All right? The 177.75, we'll call it 170. And 171.5, we'll call it 170. If we just need a very rough estimate, we can estimate beforehand and then add together, and we can get our answer of 510 calories that she's burning on average each day. Notice this one is a little bit below 170, this one's a little bit above, and this one's kind of right at 170. So it'll give us a pretty accurate answer. Nothing great, but close enough if we just want an estimate. So here, look at this. If they do it for 60 minutes, we have 185.5, we have 189.5, and we have 191.5. Now, for what you're doing here, you're going to need to make a decision. What number do we cluster to? Well, I've got my number in mind. Pick one out for yourself. Pause it if you need to. All right, now that you've picked your number, let's look and see where they clustered. Around 190. This one's a decent bit less than 190, But notice the other two are really, really close to 190. So 190 is where we cluster our answers at. When we add those all together, we get 570. All right? And that's a good average. That's a good estimate for us. All right? Look at the digit to the right of the place to which you are rounding. If it is 5 or greater, round up. If it is less than 5, round down. This is a rounding reminder. Hopefully you remember how to round. If not, this page, freeze it, will help you. All right? So, estimate by rounding to the indicated place value. They want us to estimate to the ones. Okay? So we've got to think. Ones, ones. All right? So, round to the nearest whole number. So if we look here, ones, 1 is smaller than that, so I would get 7. Okay? Because it remains the same. It's less than 5. All right? 4. We look to the number behind. All right? It is larger, so it would go up. The ones place would go up that. We have 7 plus 5. All right? We get 12. 12 would be our whole number answer if we're rounding to the ones. Now notice it's very important to read. This is not tens, this is tenths. That TH is important because this is the tenths place. This is the tenths place. We look back, we've got a 0, so 9.7. All right, minus, we look back, 0.3. Now with decimals, it's not a bad idea to always write them out. When adding and or subtracting with decimals, line up the decimals. Then you can treat it like a normal number. 7 minus 3 is 4. Bring decimal down. 9.4 is your answer. Ugly 4. We do these different things. Oh, they got the same answers we did. We subtract, and they get 9.4. We did very well. Rounding to the indicated place value, we're doing the ones again. Why don't you take a jump at it and do it? Pause the video real quick, try it, and then you can see what I did. Now that you've tried that, so I know that that becomes 6. All right, and I know that this becomes 4, and I add those two together and I get 10 as my answer. Let's see how we did this. All right. They round there, below 5 stays at 6. Above 5 goes to 4. And they get their answer of 10. Here, the tenths. All right, again, we got to look there, so you need to know your place value. Yesterday's video had a very good picture of place value, or your book has a very good picture of place value. All right, we look back. Oh, this becomes 8.9 because that goes up by 1, because 9 is greater than 5. This becomes 0.5. We do our subtraction. 8.9 minus 0.5. Very important that we line up the decimals. We got our 4 here, we got our 8 here, and 8.4. Let's see how we matched up. They got the same things we did when they did subtraction. We were on. Now remember, compatible numbers are numbers that work well together. Like 26 divided by 3 does not work very well, so we can round 26 to 27 because 3 goes into 27 very easily. That's what we're going to be looking at doing here. So compatible numbers are important and they'll make our problems a lot easier. They're numbers that are close that make the problem easier and are helpful when you're solving mentally. Okay? So estimate each product or quotient. Okay, so I see this number, that's very close to 2. So this number, I'm thinking it would be very helpful if it was 34, because I know 2 will go into any even number. So 34 times 2, we can get 68. Some of you may have said, oh, this is 2 for sure. That's really close. That could be 35, because 5s make multiplication easy. And that would be 70. I would count 68 or 70 as a correct answer, as long as you show this step of what you rounded there and kind of have a reason why you rounded. Let's see what they did. They, like the people that did the 35 and the 2. All right, because it gets a nice round number, if I would take 33.83 times 1.98, it is 70. They're showing us this because that way you can possibly estimate when we're doing the real multiplication and division and adding and subtracting with decimals and see if you're close or if you made a mistake. All right, here. All right, this is pretty close to 25. All right, and that tells me that I need this to be 75 because I know 25 and 75 are compatible, and we get an answer of 3. So my answer should be around 3 if I do this division, 72.77 divided by 26.14. Let's see what the computer did. All right, they did what we did, 75, all right, because that's around that, 25, because these two are compatible. All right. So again, let's see what things work to be or how they work out. I'm guessing they're going to make this 5, and I'm thinking since this is 22, they would probably make it 20. All right, let's see what they did. All right, they do, and that's around 100 when you multiply those two. Okay, here, this one is close to 20, so that one I would say would go to 60 because then they are, as we can tell, compatible numbers. And as long as you have your good reasons, they'll be okie dokie. All right? And they did get that 3 that we were talking about. You can also use front-end estimation to estimate with decimals. Front-end estimation means to use only the whole number. Only use the whole number. All right? That can happen, and it'll get you close to the answer, but not the exact answer. Okay? So, only the whole number, 7 plus 36 plus 5, so that would be 43, then 48. And let's see if they did. Add the whole numbers only. All right, and they did get 48. So we know it's at least 48. You might do this when you're shopping or something like that. Oh, it's going to be at least $48. I maybe should make sure I have like 53 or 54 just to make sure I have enough. So this whole or front-end estimation might be a good idea if you're wanting to make sure you have enough money and you don't want to take the time to type it into a calculator. You can also estimate a range for the sum by adjusting the decimal parts of the whole numbers. Round the decimals to 0.5, which is a half, or 1. So what does that mean? All right, 0.86, that's pretty close. That would round to 1, because that's closer to 1. All right, 0.97, all right, that would be 1. 0.4, that's close to half, so that would round to 0.5. All right, and then we can add them all and we get $2.50. You're going to either pick a half or a whole. All right, that's the idea behind this. It's a way to get an estimate. Okay. Now with this one, use front-end estimation. So I look at just the whole numbers, 8 and 47 and 3, 58. Remember, we can't add in any order because of the commutative property. All right, 8, there we go. That one ends up being 47, and this one ends up being 3, and that does give us 58 at least. All right, so you can estimate a range for the sum by adding these. So now we're going to mess with the numbers they gave us earlier, but just the cents part of it. 0.92, would that be a half or 1? Hopefully you see 0.9, we're really close to 1. All right, then 0.88, half or 1, that's very close to 1, so we're going to go to 1. The next one, 0.41, that's close to half, we will go to a half. All right, and we get 250. We'll add that to the $58 for the whole numbers. This was an estimate for the numbers after the decimal, so together $60.50 would be the cost of those things by doing the front end estimation, which got us the 58, and then looking whether it was a half or a whole that we would round to for the decimals, and then adding those two together. Okay? So that was like a two-step problem. This is the lesson, and I hope you got a good understanding for it. If not, I will be on for questions afterwards.